We just finished up with functions, so we're going to move into problem solving and data analysis. For this section, we're going to look at ratios and rates and proportions. Then we're going to go into percentages, and then we're going to go into converting metrics and also converting units of measure in the English system. And then we're going to end with statistics and probability. So for this section, there will be some problems on the SAT that are, what's the rate, or what's the ratio, or what's the percentage. But for the most part on the SAT, you're just going to be using these ideas. Okay, so it may be in a function problem, it could be in maybe a statistic problem that uses a rate. Okay, so some of this stuff you're just going to be using. Okay, so there will be some problems that look just like the problems we're going to be doing, but for the most part you're just going to need to use this stuff. Okay, so let's go right into ratios, rates, and proportions. Okay, definition: a ratio compares two different quantities, A and B, written as you can do A colon B. You can actually write A to B or A over B. I'll almost always use the fraction. I think that's easiest to work with. Okay, so it says there are 7 strawberries for every 2 bananas. Write a ratio in each of the 3 ways to compare strawberries to bananas. Okay, so we're going to write it in each of these 3 ways. We want to do strawberries to bananas, so we'll do 7 to 2. Okay, 7 strawberries to 2 bananas. We'll write 7 to 2, or we can write 7 over 2. Okay, so that would be strawberries to bananas. Number 2, write a ratio in each of the 3 ways to compare bananas to strawberries. Okay, so now we're going to be writing this backwards because we want to start with bananas. So this would be 2 to 7, 2 to 7 written out, or 2 over 7. Okay, so that's bananas to strawberries. And then number 3, it says write a ratio to compare strawberries to total fruit. Okay, so total fruit, we have 7 strawberries to bananas, so that would be 9. Okay, I'm just going to use the fractional comparison. That's the one I like to use. There are 7 strawberries and 9 total fruit, so that would be 7 to 9. Okay, next definition says a rate is a ratio in which the 2 quantities being compared have 2 different units. Okay, so it says which of the following are rates? Okay, so we're looking for 2 different units here. Number 1, 3 cups of flour to 4 cups of flour. Okay, this would be a ratio, but it's not a rate because the units, we have cups and cups, okay, or you could do cups of flour and cups of flour, is not different. Okay, so this is just a ratio. Number 2, 2 blue squares to 8 blue squares. Again, this is just a ratio. Number 3, 26 miles to 2 gallons. Okay, here we have different units, miles to gallons, so that would be a rate. I'm going to just circle that for the rate. Number 4, 4 cups of flour to 2 cups of sugar. That would be a ratio, not a rate. Okay, we're looking at cups here. That's the unit. We're doing cups to cups. Number 5, $18 over 2 hours. Okay, this would be a rate. The unit in the numerator is dollar. The unit in the denominator is hours. Okay, and then number 6, we have 3 dogs to 2 dogs. Okay, that would just be a ratio, not a rate. Okay, so rates are when the units are different, okay, but it's just a ratio. Okay, moving on to page 2. It says write each ratio or rate as a fraction. Make sure to keep the units if it's a rate. So it's very important if you have a rate that you keep the units. Okay, so top of page 2 it says, number 1, for every cup of flour you need 3 cups of sugar. Okay, the units here are cups. We don't really need to keep the units. Okay, so we have for every cup of flour, that would be for every 1 cup of flour, you have 3 cups of sugar. So that would be 1 to 3. Number 2, Bill lost 6 pounds in 3 weeks. Okay, so we have pounds and we have weeks. So this would be a rate, so we need to make sure we keep the units. So I'm going to do 6 pounds per 3 weeks. Okay, so that's his rate. Number 3, Jill makes $10 for every 30 minutes she works. Okay, again, this is a rate because we have 2 different units. So this is $10 for every 30 minutes. Okay, so when you have a rate, you keep the units. Number 4, for every 2 gallons of gas, Jake travels 34 miles. Okay, again, a rate, so we need to write out the units. So 2 gallons of gas per 34 miles. Okay, and then number 5, for every 60 miles, Karen uses 1 gallon of gas. So she would have 60 miles per 1 gallon of gas. Okay, so we just had one ratio there, the very first one, and we didn't have to write the unit. Okay, again, it's very important if you have a rate that you write out the unit. Okay, example, it says a flag is 2 feet wide and 5 feet long. Joe would like to draw a picture of it proportional to the flag. She wants the width of the drawing of the flag to be 4 inches wide. How long must the drawing be? Okay, first of all, this is just going to be a ratio because we have feet over feet. Okay, so those are the same units, so we just need 2 over 5 here. I'm going to go ahead and put width, and this was the length. Okay, you don't have to do this, okay, but just make sure you can remember what was on top, what's on bottom. Okay, so this is the flag. It has a 2 to 5 ratio of width to length. Okay, and it says Joe would like to draw a picture of it proportional, so we have to keep this ratio. She wants the width of the drawing to be 4 inches, so she wants the width to be 4, and how long must the drawing be? Okay, so there's a couple ways we can do this. You could just think through, okay, 2 times what gives us 4, or 5 times what would give us, so 2 times 2 would give us 4, so then we're going to have to do 5 times 2. I'm going to go ahead and put an X here and solve by using cross multiplication, okay, just because they're not always going to be this nice. So if this was, this number here was maybe an 11, okay, you'd want to do cross multiplication. Okay, so we want to cross multiply. That gives us 2x equals 5 times 4 is 20. So x needs to be 10, and the unit here was inches. Okay, because she wanted the flag to be 4 inches, so the length would be 10 inches. Okay, next example. Susan makes $13 per hour. This per means to divide. Per is to divide, or put a division line. How much will she have to make? How much will she have to work to make $52? Okay, so let's go ahead and write out her rate here. So her rate is $13 per hour, so 1 hour. Okay, notice this is a rate, so I kept the units. Okay, how much will she have to work to make $52? Okay, so we want the numerator to be $52, and we want to know how much she's going to have to work. Okay, again, cross multiply, that would be 13x equals $52, and then we have an hour here. This is also dollars. Okay, I'm keeping the units here. You don't have to do this, okay, but just make sure you understand what the end unit should be. Okay, so to solve for x, we divide by $13. Okay, that gives us x equals, the dollars cancel, 52 divided by 13 is 4, I believe. Okay, the unit we're left with is an hour. Okay, so 4 hours. Okay, again, I went ahead and put the units here. I'll do this. Hopefully I have another rate, probably later. I'll have another rate here that I'll keep the unit. If you don't keep the unit when you're solving, just make sure you understand what the answer should be. Okay, next example, the ratio of boys to girls in a class is 5 to 7. If there are 14 girls, how many boys are there? Okay, so let's go ahead and write out that ratio. The ratio of boys to girls is 5 to 7. I'm going to just put a B here and a G here for girls, just so we remember what we put on top. If there are 14 girls, how many boys are there? Okay, so we want the girls to be 14, and we don't know what the x is. That's what we're solving for. Okay, again, cross multiplying, which, let me do 14 times 5 here. That's 70 equals 7x. Okay, solving for x, x would be 10. And the solution was in boys. Oops. Okay, so that was page 2. Moving on to page 3, that actually ends the ratios and rates, and page 3 is percents. okay, which percents is really just a ratio or a rate. Okay, so it says when we say percent, we are really saying per 100. Okay, remember this per means a division line. Okay, so that means percents can always be turned into proportions, okay, which are ratios or rates. Okay, so 25% means 25 per 100, or we write that as 25 over 100. Okay, example, it says 25% of 400 computers in a school are laptops. How many computers are laptops? Okay, so we have 25% of 400. Okay, 25% is 25 per 100. Okay, that means for every 100 computers, 25 are laptops. Okay, so we're going to solve this just how we would solve a ratio or a rate problem. So we have our 25% is 25 over 100. That's our ratio. And we have 400 computers total. Okay, we want to know how many are laptops. So here's our X here. Okay, so solving, we want to do 400 times 25, which is 10,000. And then that would be equal 100x. Okay, so divide by 100, that should give you 100. So this would be 100 laptops. Okay, one more. 5% of 200 squares are yellow. How many yellow squares are there? Okay, again, we want to do the ratio for 5%, which is 5 per 100. Okay, we know that there are 200 total squares. Okay, and then 5 out of 100 are yellow. Okay, so here's our X. So 200 times 5 is 1,000 equals 100x. Divide by 100, you should get 10. And that would just be squares. So we have, oops, I'm not spelling tonight. So we just have 10 squares are yellow here. Okay, so that is how percents or proportions are made into proportions. Now we're just going to go into key principles for percentages. Okay, so you don't have to do this work every time you see a percent. Okay, so now we're going to go into some shortcuts to percents, which you probably have seen before. Okay, so the first one is convert percent to decimal. Okay, so you're given a percent, you want to change it into a decimal. What you do first is you delete the percent sign and then divide by 100. Okay, so let's look at this 45%. Okay, we want to change 45% into a decimal. So you delete the percent sign, so you have 45 here, and then you divide by 100. Okay, which you can get out your calculator for that, but dividing by 100 is actually very easy. You're going to take your decimal and just move it over 2 places. Okay, which I'm going to write move decimal 2 places to the left. Okay, and again, you can check this with your calculator. Okay, so here's my new decimal. Okay, so 45% is the same as 0.45. Okay, next example, convert 4.39% into a decimal. Okay, again, delete the percent sign. Okay, take our decimal, move it 2 places to the left. Okay, now we have a blank here, so we're going to add in a 0. So 0.0439 as a decimal. Okay, number 2, we're going to go backwards. We're going to convert a decimal to percent. Okay, so we're doing exactly opposite of what we've just done. A is multiplied by 100. Okay, now we're going to be moving the decimal 2 places to the right. Okay, and then B, attach a percent sign. So exact opposite of what we just did. Okay, top of page 4 says convert 0.95 into a percent. Okay, so we take our 0.95, we're multiplying by 100 or moving it 2 places, decimal 2 places to the right. So here's our new decimal. That would be 95%. Next example, 0.003. Okay, again, moving this 2 places to the right. So that would be 0.3%. Okay, again, you've probably seen this before. Okay, the third one, converting a fraction to percent. A, divide the numerator by the denominator. B, multiply by 100. Okay, since we're multiplying, we're just moving decimal 2 places. Multiplying would be to the right. Okay, and then attach a percent sign. Okay, example, convert 3/4 into a percent. Okay, so we're going to do 3/4. We're going to divide numerator by the denominator. So 3 divided by 4, that's exactly what a fraction is. Let me turn this down, it's a little bright. That is 0.75. If you do that in your calculator, you probably know that already though. Okay, then it says multiply by 100. Okay, or you move the decimal 2 places to the right and attach a percent sign. So that would be 75%. Okay, and then the last one, 4, it says to find percentage of an amount without using ratios. Okay, so what I mean by that is we've already done this. Okay, we've done 25% of 400 or 5% of 200, but we've used ratios here, which is actually the long way around. Okay, so this is without using ratios. Okay, you drop the percent sign, divide by 100. Okay, this is dividing means move decimal 2 places. Dividing is to the left. Okay, and then you multiply by the total. Okay, so bottom of page 4, it says find 6% of 1200. We're going to use ratios first to solve, just so you can see how these are the same answers. And then we're going to check the answer with the above steps, which is actually simpler. Okay, so 6% as a ratio is 6 over 100. So remember, 6% is 6 per 100. And we have a total of 1200. So here's our total. Okay, we want to know how many that is. How many is 6% over 1200? Okay, so we need to do 1200 times 6, which is 7200, equals 100x. Divide by 100 to solve, you should get 72. Okay, so x is 72. Okay, now we're going to check our answer with the above steps. So it says drop the percent sign, so now we just have 6. We're going to divide by 100. Okay, we're basically just changing the 6% into a decimal. Okay, so we have 6. We're going to move the decimal 2 places to the left. That gives us 0.06. Then we multiply by the total, so 0.06 of 1200. Okay, you should get 72 here. Okay, last example on this page, it says 49% of 891 online shoppers use Amazon. How many online shoppers use Amazon? Okay, so we want to do 49% of 891. Okay, so we're going to change this 49% into a decimal, which if you go through the steps, you'll get that it's 0.49. Then we're going to multiply by 891. You should get approximately 437. I rounded here. Okay, because you can't have a decimal of a person since we're using online shoppers. Okay, on to page 5. We're still working through percents. Okay, so this is finding interest, taxes, or any other percent added or subtracted to a total. Okay, again, you've probably seen this before. This is going to be a little different than what you've probably seen the work. If you don't like the way I work through this, just use the way that you have been taught. You're going to get the same correct answer. Okay, so this is any percent added or subtracted to a total. Okay, so like if you're tipping at a restaurant, you want to do 20% to your total. Okay, so you're adding or subtracting that to the total. Or if you were saying a shirt is 75% off, you're going to subtract 75%. Okay, so it says change the percent to a decimal. Okay, we know how to do that. This percent will be negative if you're subtracting from the total. Okay, so if it says 75% off, you want your percent to be negative, so negative 0.75. Number 2, add the percent to 1, and then 3, multiply the number you found in number 2 by the total. Okay, so this is just a shortcut of finding percents. Okay, so example, it says Cindy's total at a store is $26.23. There is 6.5% tax added to her total. That should not be a question mark. How much will she owe? Okay, so let's go ahead and go through these steps. It says change the percent to a decimal. Okay, so this as a decimal, 6.5%, would be 0.065. Okay, add the percent to 1. Okay, so now we're going to add 1, and we get 1.065. Okay, now we multiply the number, this number that we found, by our total. So we're going to do 2623 times 1.065, which I have to use my calculator for that. And I got about $27.93. Okay, so let me just go through the way you might have learned it. You might have learned it this way, which is great. If you have not learned it this way, you've, I'm assuming, learned this. So you change the percent to a decimal. You would have multiplied that by 2623 times 0.065. 26.23 times 0.065. Oops. Okay, so you would have got about $1.70. Okay, and then you would have added that to the total. So then you would have added 2623, which is still going to give you 27.93. Okay, so the way you do it, if you do it this way, okay, it's still going to give you the correct answer. This is just a shortcut. I want to show you why this works. Okay, so the way you did it, if you do it this way, is you're multiplying by the percent, okay, which is this, and you get that. Okay, then you add in the total, okay, which is the same as multiplying by 1, okay? So you're adding it to 1. So that's exactly what we did. We took the percent, we added 1, okay, which this as a percentage, okay, 1 as a percentage is the total, 2623. So once we added that, this number here gives us 100%, okay, plus the 6.5%. Okay, so what we're doing when we multiply this, we're saying take 100% of this and then add the 6.5%. Okay, so this is just a shortcut. We're going to do one more like that. Okay, it says Eddie has a total of $63.45 at a restaurant and wants to give a 20% tip. How much will his total be? Okay, let's go ahead and change this 20% into a decimal. So that's 0.2. Okay, then we're going to add 1. Okay, so that would be 1.2 here. Okay, so we're going to have 63.45 and we're going to multiply by 1.2. Okay, so 63.45 times 1.2. You should get, oops, 76.14. Okay, so that's how much his total will be. Just because I didn't give an example down here, if you were doing, let's say, 75% off, let's just do $20. Okay, since we didn't do a subtraction one, 75% as a decimal is 0.75. Okay, here we're not adding it, we're actually subtracting it. So we want to subtract from 1. Okay, so that would be 0.25. Okay, so then you would take $20 and you would multiply by 0.25. Okay, so this is just a different example. Okay, and we're going to do a couple more things with percents and then we'll move on. Bottom of page 5, we have translating percent problems. Okay, we use the formula A equals P times B, which means A is P percent of B. Okay, so P stands for percent. Okay, this equal sign you would always say is or equals, and of means multiply. Okay, so A is going to be your solution. Okay, P is the percent, and then B is what we're multiplying by, or the total. Okay, so these problems can get kind of confusing. Okay, so if you always use this A equals P times B, I think you'll be okay. Okay, so number 1, it says, what is 4% of 83? Okay, so using this formula, P is the percentage, okay, or 4%. Of would be 83 because this of is multiply, okay? So we would write A equals, P is a percent or decimal, so 0.04 of 83 times B, so 83. Okay, and we would just multiply this, so 0.04 times 83 should get A equals 3.32. So the answer is 3.32. So 4% of 83 is 3.32. Okay, you probably could have figured this out without this formula. Okay, but we're going to look at some more examples here. Okay, number 2, 32 is 53% of what? Okay, so we have P, that's a percentage. And here we have A. We have the solution. We don't have B. Okay, so A is 32. 53% is 0.53, and now we don't have B. Okay, to solve for B, you divide by 0.53 on both sides. Okay, so 32 divided by 0.53, you should get B is about 60.38. Okay, so 53% of 60.38 is 32. Okay, on to page 6, we just have a couple more of these. Okay, again, I'm going to write at the top here, A equals P times B. Okay, number 3, we have 3 is what percent of 20? Okay, now we don't have the percentage, so we're going to solve for percent here. A would be 3, we don't have P, and then B is 20. Okay, so we're solving for P here, so divide by 20 on both sides. So P is 3 divided by 20. Okay, we just want to change this into a percent now. Okay, so if you divide out, that's 0.15. As a percentage, that would be 15%. Number 4, 18 is what percent of 45? Okay, so again, we're going to do the same thing. 18 is our solution. P, we don't know. And then B is 45, which I should put that in parentheses. It looks kind of messy. Okay, solving for P, you divide by 45. So P is 18 over 45, which actually gives you 0.4, which is 40%. Okay, and then one more, number 5, 30% of what number is 6.8? Okay, so let's break this down. We have the percentage P. We have of what number? Okay, that means we don't have B. Okay, and then we have is 6.8 or equals 6.8, meaning we have A. So A is 6.8. We do have P, which is 0.3 as a decimal, and then we don't have B. Okay, solving for B, we divide by 0.3 on both sides. Okay, which I can't do that in my head. So 6.8 divided by 0.3, I got about 22.67. Okay, so 30% of 22.67 is 6.8, which you can check that. Okay, so that ends the percents. So we're going to go ahead and stop there. And once we pick this back up on page 6, we're going to start converting